Hey everyone, today we're going to review exponential properties. The first one we are going to review, if you can remember, on the formula sheet. And remember, anytime on your PSSAs that it's giving you a problem with exponential properties, look at that formula sheet. It is definitely on there. The first rule we will review is a to the m times a to the n. Remember, when you have the same base and you're multiplying, you add your exponents. So down here's an example. I have the same base of x and I'm multiplying. So literally I'm just going to add my exponent. X and 3 plus 2 gives me 5. So my final answer would be x to the 5th. Let's try this one. So this one's only a little bit different because of these coefficients out in front. So whenever you have coefficients out in front, you actually still multiply them. So I would have 3 times 2 would give me 6. And remember, when I have the same base and I'm multiplying, I add my exponents. So I would have x to the 4 plus 7, which in this case my final answer would be 6x to the 11th. Now this one's a bit longer, but you follow it the same way because we are multiplying. Remember, if you see parentheses, that means to multiply. So the first thing I'm going to do is multiply my coefficients out in front. So 5 times negative 2 is negative 10. Negative 10 times negative 3 is a positive 30. Now I'm just going to add my exponents with the same base. Remember, if there's not a number, an exponent above your base, put a 1 there. That might help you. So that's what I'm going to do with all of those. So now I can combine my a's. So I have a to the 1 plus 1 for these two here. I have b to the 2 plus 4 because of this and that. And then lastly, I have c to the 1 plus 4 because of this and this. So now I can just write my final answer, which would be 30, a to the 2nd, b to the 6th, c to the 5th. Alright, I hope that refreshed your memory when we were multiplying with the same base. Now we are dividing by the same base. And when you divide by the same base, all you have to do is subtract. So here I have a base of 6, so I'm going to rewrite my 6, and I'm going to subtract my base, or excuse me, my exponent. 3 minus 1 is 2, so my final answer would be 6 to the 2nd power. Next one, I have the same base. My base is x, and I'm going to subtract my exponents. 17 minus 2 would give me a final answer of x to the 15th power. This one, just like before with multiplying, if you have these coefficients out in front, you're going to perform the actual operation. So in this case, I'm going to take 24 and divide it by 6. So 24 divided by 6 would give me 4. Now I'm going to follow the rules for dividing by the same base. So I have a base of x. My exponents would be 5 minus 2. And I have a base of y. And I would be subtracting 8 minus 3. So my final answer would be 4 x to the 3rd, y to the 5th. Same thing. Let's try this one. 8 divided by 2, because remember you actually perform this operation with your coefficients. So 8 divided by 2 is 4. Then I have k to the 5 minus 1. Remember, if you don't see an exponent, put a 1 in. And you have b to the 6 minus 6. So my final answer would be 4 k to the 4th. b to the 6 minus 6 is 0, and remember, anything to the 0 power is just 1, so they cancel out. So your final answer would be 4k to the 4th. Technically on this problem, you don't even have to write this part down, the b's down, because if you see it's the same value in your numerator and your denominator, you literally could cross them out. Just another strategy to solve that problem. The next one, so this is a two-stepper. I'm going to perform the operation that is in my numerator first, and that would be the rules for multiplying. So I'm going to do that in green. So I'd multiply your 3 and your 6, so 3 times 6 is 18. Remember when I have the same base, I add 5 plus 1 would give me 6. B to the 1 plus 3 would give me 4. I'm going to rewrite what is in my denominator. And now I'm just going to follow the rules for division now. So 18 divided by 9 would give me 2. A to the 6 minus 2, because remember when we divide we subtract our exponents, would give me 4. B to the 4 minus 3 would give me 1. Or technically you could have 2a to the 4th b. This would mean the same thing. Remember, as you're going through this, if you still don't understand, please ask your teacher and always have that formula sheet handy. Next rule, when I raise a power, whoops, I didn't mean to do that. Let me erase that. Remember, when I raise a power to a power, which I'm doing here, I'm really multiplying. So remember, raising a power to a power, you multiply, which you do not have to remember, it's on your formula sheet. And when you multiply, you can think of it as distributing. So this would be x to the 4 times 6 is 24, y to the 2 times 6 is 12. That is your final answer. Next part, I'm going to distribute into every single term. But remember, just like when we had coefficients out in front for multiplying, you actually multiply, divide, you actually divide. Here you actually are going to raise it to the power of 3. So that would become 5 to the 3rd. X, when you have an exponent raised to another exponent, you multiply. 3 times 3 is 9. Y to the 4 times 3 is 12. So I'm not done yet. I have to figure out what 5 to the 3rd would be, which in this case that is 5 times 5, which is 25, times 5 again is 125, x to the 9th, y to the 12th. Next one, same exact thing. Distribute that 4 into every single term. So this time I would have negative 2, and remember when you have a negative base, you put it in parentheses to the 4th power. K to the 6 times 4 is 24. D to the 5 times 4 is 20. I'm not done yet. I have to do negative 2 to the 4th power, which I'm going to write off to the side. This would be negative 2 times negative 2 times negative 2 times negative 2. So negative 2 times negative 2 is 4. And that again, and 4 times 4 would give you a positive 16. Or technically, you could have typed it in your calculator, but just make sure if you type it in your calculator, you put parentheses around your negative base, or you will not get the same answer. This rule, hopefully you remember, anything to the 0 power would always be uno, 1. The last rule that is on your formula sheet is when you have a negative exponent. Remember, we do not like to have the negative exponent. So when you have the negative exponent, you want to change its location. If it's not in a fraction, put it over 1 and change its location. If it's in the numerator, put it in the denominator. If it's in the denominator, put it in the numerator. And when you change its location, remember your exponent then becomes positive. So this one right here, b to the negative 4th, if you get confused, put it as a fraction, so put it over 1. I do not like that negative exponent in my numerator, so I need to put it in my denominator. When that happens, my exponent becomes positive. I have nothing left in my numerator, so you always put a 1 if there's nothing in it. This is where some of you want to put all of this in the denominator, but remember you only put the base with the negative exponent. So this would become 5x would still stay in your numerator, y to the 6 would go to your denominator, because only the base that has the negative exponent is where you change the location. This one involves a few steps. The first thing I'm going to do is distribute that in to every single term. So this would become negative 10 to the negative 2nd, x to the 4 times negative 2 is negative 8. Y to the, remember, 1, if it's not listed, times negative 2 is negative 2. All of these have negative exponents. So the next thing I'm going to do, since they all have negative exponents, I'm going to change the location of every single one. So everything must go in my denominator. Negative 10, and remember when you switch its location, the exponent becomes positive. So each exponent will become positive. There's nothing in my numerator, so I'm going to put a 1. A lot of you will think that problem's done, but technically it's not, because you have to figure out what is negative 10 to the second power. Well, you can think negative 10 times negative 10, or plug it in your calculator, and that would be positive 100. So my final answer would be 1 over 100, x to the 8th, y to the 2nd. Next problem. First thing I'm going to do, as always, is distribute that in, and when you distribute, when you raise a power to a power, you multiply. So that would become b to the negative 12th over k to the negative 28th. Remember, you do not want a negative exponent, so you actually need to change the location of each one of those. So I would put k to the positive 28th in my numerator and b to the positive 12th in my denominator. Let's look at this one as well. So this looks like I'm multiplying. So let's perform the rules for multiplying, which, remember, we multiply our coefficients and we add our exponents with the same base. So 4 times 3 for my coefficients would give me 12. A to the 3 plus negative 4 is negative 1. B to the 2 plus negative 3 is also negative 1. Remember, you do not want to have any negative exponents, so you need to change the location. 12 does not have a negative exponent with it, so that can actually stay in your numerator, and then you would just put a and b in your denominator. Well, I hope this video refreshed your memory on exponents and properties of exponents. Now you can start your homework, which is in Schoology, and as always, ask your teacher for help if you need it. Thanks so much and have a great day.